Hello, hello. This is a nice time for you to spend the Saturday's evening and have pleasure and have fun and introduce something new for our watchers. Welcome, Tim. Welcome, Vladimir. Welcome, Maxim. Nice to meet you here. Thanks for joining us. Vladimir, can you please tell more about what we're going to do tonight?
Well, hi there. I'm really glad to have Tim to describe OP for us, and it is really interesting to see how the agent integrates with applications. But before we begin, Tim, can you please clarify who is the target audience for Open Policy Agent? Is it needed for everybody or for some specific group of engineers?
Yep. So first of all, thanks for having me. I think this will be a lot of fun. So yeah, the users of OPA, there are a bunch of different users of OPA. So platform engineers, people who are responsible for Kubernetes, the public cloud, those folks really use OPA quite a bit. You can also think about OPA users being application developers. So the people who are responsible for writing the code, the applications that run on top of Kubernetes or the public cloud. And so those are usually the two groups of folks that we see using OPA and putting OPA in place. But the key thing to keep in mind is that the whole idea behind OPA, having a clear way of codifying and enforcing policy, is great for the entire organization, right? So from the individual folks that use it day in and day out, all the way, which is typically engineering, but to security as well, to compliance, operations, really the whole organization benefits from OPA.
Yeah, and that's nice. The OPA was created several years ago, right? And did you imagine it would came as such a big project as it currently is?
Well, you always hope that it's going to be a big project when you start something, for sure. We knew there was a lot of potential there. We knew that the problem that OPA solved was real, for sure. And so then we just had to make sure that we solved that real problem. And that's sort of how we thought about the project, build that policy as code implementation, and then make sure that we could show people how to use it by integrating it with a number of software systems like Kubernetes and Envoy and so on and so forth, and actually show people that it can be used to solve real problems that they have today. And so that's certainly the approach we took, and I think it's paid off well.
Yeah, one of the nice things about OPA is it's not using YAML, so it's using its own language. Can you please clarify what's the intention there?
Yeah. So OPA does have some people like to call it a domain-specific language. That language was designed specifically to make it possible for you to write policies, right? It is designed to be a policy language, right? Not a programming language, not a data format like YAML, but rather a policy language. And the idea there was just that, once you've written enough policies, what you find is that you do need language that was designed for policy, and that allows you to make it easier to write those policies to begin with syntactically. But then what it also does is it allows OPA's policy engine to be able to sort of understand those policies far more deeply and handle more of the performance concerns than you could if it was a traditional programming language.
So I know that our technical team have lots of tricks they can do with the video stream. And one of the tricks is to make the host, me, to disappear. So, Maxim, are we ready for the kicking off this talk right now?
Yeah, I think we're ready.
So Andrew's disappearing and your virtual studio is yours.
Excellent. All right. Well, yeah, let's get started. Okay, great. So hopefully those slides are coming across and our experts will let me know if there are any technical issues here. Like we said, my name's Tim Hinrichs. I'm the CTO and co-founder here at Styra, one of the co-creators of the Open Policy Agent. Today, what we're going to be talking about is the Open Policy Agent. We're going to give you an introduction to it, why it exists, what the community is around it, how you can integrate it into software systems, and then we'll also talk about the tooling and some of and show you some of the policy language so that you can get a hands-on feel for it. We'll also try to do a demo and show you someone using OPA in action, and so hopefully that'll be good. Please do ask questions throughout. However you want to do that, you can do that by asking questions in the chat, and then periodically we'll go ahead and have our experts ask me what those questions are. So the way to think about how this gets started is when we started Styra and when we started the Open Policy Agent, we made a very simple observation that many folks have made, and that is that there are so many organizations today that are embracing all of these mega trends around microservices and DevOps and automation, self-service, CI/CD, and cloud technology, right? All of those major trends are fundamentally changing how we build and how we run software today, right? And so one of the observations we made was that because all of those software processes are changing, because of the stack of software that we're using to run and build our custom software is changing, there are a bunch of impacts around security. And so, here at the bottom, we list a few of them. I'll go through a couple of them. When I think about microservices, one of the security impacts that I see around microservices is sort of depicted here on this slide. So instead of a relatively few number of internal communications between services on the left, you end up with a whole collection of internal APIs on the right. And from a security point of view, what that ends up doing is it's fundamentally increasing the attack surface, right? Because once an attacker breaches that outer environment wall, suddenly if they take over one of these nodes, they've got all these rich APIs that were designed to be used. And so therefore they can, therefore all of those APIs are attack targets now from a security point of view. And I would estimate there that it is roughly 10x larger, simply because you've got 10x more microservices than you had services in the old days. And moreover, because they're all designed around like RESTful or gRPC APIs, you do need to protect them. If I think about the cloud, what is the impact from a security point of view? Well, it used to be that we owned all of the hardware that we ran software on. But in this new world of DevOps and microservices, when we're running things on the cloud, we don't own that hardware anymore. We can't go and physically disconnect wires if there's an attack. We're relying on the fact that our cloud providers are the ones who are protecting us at the physical layer. And so that just means we have less control over the network and the data center. If I think about CI/CD and automation, one of the things that we see people do all the time is take those custom software applications and deploy them to a broad array of different environments. And so no longer is it the case that we can rest and put all of our security controls on the perimeter here, right? Because we don't know where those applications are going to be deployed. They may be deployed to a bunch of different environments. And so relying on simply the perimeter to enforce security controls is pretty dangerous today. If I think about DevOps and self-service, what I think about is lots and lots of new people who have access to production environments, right? In the old world, we had an operations team that was dedicated to running all of that software. And that was great in the sense that there were relatively few people. You knew the operations team was responsible for production. In the DevOps world, we've got tons and tons of people responsible for accessing production and keeping those applications running. And that's the whole idea. And so from a DevOps perspective, we just have 10x more people now who are involved. And so again, that's going to influence security because now we have to think about making sure that we have access controls in place for all those additional people. So there are a whole bunch of other changes that are coming around because of all of these modern DevOps and microservice trends. But here are the few that I'll call out. Now, the one that I'm going to focus on today is really authorization. So this is one piece of security, or at least people typically think of this as one piece of security. And what I'll call out is that in this cloud and microservice world, authorization is more important than ever, right? And so remember that authorization is this problem of controlling actions that get taken on software. So sometimes those actions are taken by people, sometimes they're taken by machines. Those actions are often API calls that are being performed. And what you're sort of trying to control is who can perform those actions or those APIs on which pieces of software, potentially on which resources that are controlled by those pieces of software, and in which environments. And then the list goes on and on about the other kinds of things that you can think about controlling authorization using. So that's authorization. I'll contrast that briefly with authentication. The two are often confused. So remember that authentication is a problem of like signing in, logging in, convincing the machine that you are who you say you are. So when I log into my bank account or whatever, I convince the bank account that I am actually Tim. The actions that I perform, like withdrawing money, transferring money within my account, those would be the problems that are solved by authorization. So today we're going to be talking about authorization. And when we think about authorization in this cloud native world, in this DevOps world, there are a whole bunch of there are a handful of new requirements. I'll call out a few of them here. So one of which is that when you think about authorization, the space of these authorization decisions is just broader than it's ever been. If I think about the public cloud and AWS, I think about they've got thousands of API calls. There's one piece of software that has thousands of API calls, and each one of which is pretty powerful in its own right. So the space of decisions here is just quite a bit larger than it's ever been before. The other thing that I'll call out, and that we've already spoke to, is the idea that in this cloud native world, you want pervasive enforcement. So you don't want to just enforce authorization at the edge, right, at the gateway where maybe your application is running. You want authorization enforced within every piece of software. And sometimes people will call that zero trust, or a piece of zero trust. And then the other thing that I'll call out there is the policy lifecycle. So the idea here is that the lifecycle, as you write policies, one of the things you want to do is ensure that those policies go through a lifecycle where you have a policy authoring phase, you give it over to peer review, maybe you run some unit tests, maybe then you have to go ahead and deploy those policies to wherever they need to be enforced, and you need to monitor them and log them. And so there's an entire life cycle that you want to put policies through, because at the end of the day, in this microservices, DevOps, this cloud native world, you want everything to work as code, and policy is no exception to that. Because at a high level, one of the things that's super important in this cloud native world is that we ensure that we can automate all of those policy checks, all those security, compliance, and operational checks. Because if we don't automate them, then all of the work that we're doing around DevOps and cloud native and microservices is going to be slowed down by manual security, compliance, and operations checks. And one of the things we want to make sure we do in this cloud native world is automate everything. And that's the way that we're going to deliver, at the end of the day, one of the high level goals for cloud native technology. And that is that we want to deliver software faster to our end users than ever before. We want to be deploying software on the order of minutes instead of months. And in order to do that, we need to automate everything, including all of these policy checks that people have to go through. The key observation that we made at the beginning of the company and the beginning of Opa is that really authorization happens everywhere, at every layer of the stack within cloud native. So here's our canonical drawing of all the different places within the stack that you might see, right? So hopefully this all looks familiar to you. At the CI/CD pipeline, anytime somebody tries to check code into a source repo, or they try to deploy an application, there are authorization checks that need to be made. Is that source code safe to go in? Is that application safe to deploy? Anytime somebody goes and uses Kubernetes and they try to deploy a new pod or a new ingress to Kubernetes, is that pod or ingress safe to put onto the cluster? Anytime a microservice receives or sends an API call, is that API call safe to evaluate, or is it not? Anytime someone is using an application, they're performing an action. Maybe I'm trying to withdraw money from my bank account. Is that authorized or not? Every time somebody in a database tries to run a query or update a table, is that safe or not? Is that authorized or not? Anytime somebody tries to change the configuration of the public cloud, is that safe or not? Is that authorized? Anytime somebody SSHs into a server, into a Linux server, or tries to spin up a new Docker container, is that authorized or not? So the observation that we made here was that there's authorization really everywhere within cloud native. At the same time, when you think about solving the authorization problem, there are a couple of different things that you need to think about. So the first of which is that, well, somebody might come along and say, hey, can you please tell me who has access to all these different software systems? What is the authorization posture? What are the authorization policies that exist across all of these different pieces of software? So that's the audit problem. Then there's the enforcement problem, which is somebody says, oh, well, we had an outage and we figured out why, because maybe somebody misconfigured a Kubernetes pod and didn't put resource limits on it. And so we want to enforce the policy that says every application that gets deployed must have resource limits enforced. So now that enforcement problem is the second one. And so either one of these problems that you want to solve, really the question becomes, well, how do you do that, right? Before OPA, before Styra, every one of these different pieces of software had a different way of solving that authorization problem, right? Kubernetes has its own, every microservice had its own, the database have their own, public cloud has their own, servers have their own, CI/CD has their own. And so, from I as an operator, I as someone who's responsible for actually using and running these software, making sure that they're being used safely, I need to understand how each and every one of these different pieces of software allow me to enforce authorization policies in order to solve either of these audit or enforcement problems. And so the way that people have typically dealt with authorization in the past is, well, one is they just sort of train people and they say, well, you know what, if you have to have, everybody just needs to know that they need to have resource limits on all their applications. So that's one option. Another option that we see sometimes is that people will go ahead and hard code those policies into each of these individual pieces of software. Most often that's in the microservice or custom application use case, where people just write logic into their application that says, well, is this API call authorized or is it not? And then there's a third option here, which is probably the most common, especially in this cloud native space, which is that each and every one of these pieces of software have a different way of configuring the authorization policies, right? So, and so in any of those cases, what we see is that there are real challenges in operationally, because now, regardless how they're implemented, each and every one of these different pieces of software has their own API, their own GUI, their own authorization model. And so as a user, as an end user, I have to figure out what all those are. And that, in some sense, it seems kind of silly, right? Because authorization, you can define it fairly simply. It's which people or machines can access which resources and in which ways. And so conceptually, what we know is that all of those authorization policies share a lot of just simple and/or logic. But at the end of the day, I, as an operator, have to understand a whole bunch of different ways of enforcing authorization. So that is why we started the Open Policy Agent. The Open Policy Agent is its primary goal is to provide a unified solution to authorization across all of these different cloud-native software systems. So the idea here is that instead of learning 57 or however many different APIs and GUIs for authorization, instead the idea is that you use OPA, and in so doing, you learn one API, one policy language, one paradigm, one way of thinking about authorization for all of these different software systems. So there are really three things that I call out here in terms of what OPA provides. The first of which is a file format, so that policy file. The idea is that there are plenty of file formats for images and for movies. Well, OPA provides a file format for describing policies, for describing those rules and regulations in a machine-readable format. So that's called, the language for expressing those policies is called Rego. The second thing OPA provides is a policy engine. That engine understands and can read and interpret that policy file. So you hand the policy file over to OPA, and now OPA knows, the policy engine knows how to go ahead and make decisions, policy decisions, using that policy file. And then the third thing that OPA provides is policy tools. So like I mentioned, one of the goals here for the Open Policy Agent project is to provide an entire life cycle, allow you to embrace a policy as code paradigm for enforcing authorization across the cloud native stack. And so as part of that, there are a number of tools that OPA provides, like a unit test framework, a benchmarker, a profiler. It provides integrations with IDEs. And I'll talk more about some of those in more detail a little later. But those are the three main things that OPA provides. The other thing, as I mentioned at the very beginning, was that we went ahead and to sort of demonstrate how to use OPA, we did integrations of OPA with a number of these different software systems that you see here. One of the most popular there is probably Kubernetes, using OPA to control which pods or which ingresses or which other resources get deployed onto Kubernetes. Using OPA to control microservice API authorization is another very popular use case. There are also some heavy users of Opa with Kafka to control, let's say, sensitive topic reads and writes. Terraform is another popular use case for Opa. Also, using Opa within a CI/CD pipeline is also pretty popular. And then the one I always kind of chuckle about is using Opa for like controlling who can SSH into a Linux server. That's usually a follow-on in terms of once you've already got Opa running for one of these other use cases, then you realize, well, I might as well use it to control who can SSH into a server as well. But the thing that I'll point out here is that all of these different examples of where you can use Opa are not just theoretical. All of these different categories are categories of software where someone has already deployed Opa in production at scale today. So these are realistic use cases for Opa. Now is one more slide here before we pause, I think, for questions. So there are really a number of high-level things that Opa provides. And so one of the things that Opa provides is a sort of a declarative approach to policy, and unified policy, obviously, but a declarative approach for policy. So the language that you use to express those policies is a completely declarative language. I spoke earlier about how it is purpose-built for expressing policy, and so we'll see some of that. The second thing that Opa provides is the ability to sort of decouple those policies, those authorization policies, from the underlying software, right? So instead of hard coding policies or configuring policies inside of Kubernetes or inside of your microservices or inside of Kafka, instead you pull those policies out and you hand them to Opa. That's how you achieve that unification, which is that you need to decouple. You need to pull those policies out of that underlying software and hand them to Opa. And that's pretty powerful because then you can utilize Opa for all those different use cases. The policies are also very portable. So one thing that we see people doing is writing the same policy. And let's say they write the policy and it's intended originally to be run and enforced within Kubernetes. And so every time somebody tries to go ahead and spin up a new pod or a new ingress in Kubernetes, then you can configure the Kubernetes API server to ask Opa whether or not that's safe. And so that's maybe the first place that you enforce that policy. But then you can take that policy because you've decoupled it, and you can go ahead and decide, well, we're embracing GitOps. So what we're telling all of our engineers is that they need to check those Kubernetes resources into Git before they are deployed onto Kubernetes. And so what you actually want to do is enforce those policies not only at the Kubernetes API server level, but you also want to enforce them at the CI/CD level. And so the policies are portable. It's great. You can go ahead and do that if you so desire. The fourth one on that list is that Opa is open. It is a completely open source project, and I'll speak more about that in a little bit. We started it at Styra, but then we donated it to the Cloud Native Computing Foundation. It has been an open source project from day one. Each and every single one of the lines of code that belong to Opa have been done in the open. So that has been part of the design from day one. And then the final thing there is that Opa does allow you to write context-aware policies. And I'll talk about this with some examples a little bit later. But the idea is that with Opa, you're making decisions based on not just the Kubernetes pod or the ingress or the microservice API that it was asked for a decision about. You can also leverage arbitrary external data, information about what's going on in the world in order to make decisions. And so in that sense, it allows you to write context-aware policies. All of these different properties are pretty important throughout the different use cases. And so we'll go into more detail a little bit later. Okay, so that is a good time to pause and see if there are any questions from the audience or our experts.
Thank you, Tim, for introduction. That's really awesome. I wonder at this point, for instance, what if I have a PostgreSQL database? Is Opa suitable for making policies, and where can I really find the ready-made integrations? So is there some index page that lists their pre-made integrations?
Yep, good question. So yeah, there is, and maybe what I'll do here is we'll hop out of this. So I'll answer the second question first, which is if we go to openpolicyagent.org, if you want to find a list of integrations, there's a link to it, integrations. And so what we try to do here is give you this page of the different kinds of integrations that either we or the community have done with Opa. Now, each of these integrations is sort of a different level of maturity. What we've tried to do is roughly categorize them by maturity based on sort of like how much information there is about each of these different integrations. So in this page, I opened up the first one, Kubernetes admission control. What you can see underneath is that there are plenty of different folks who are working on this integration. There are a couple of different places of actual chunks of code. There are plenty of tutorials that you can look at, or there are a couple of tutorials, but then there are plenty of videos of different folks using Open. So, some of these are going to be obviously out of date, but nevertheless, this is, the kind of information that we're trying to give people about each of these integrations. The other thing that I'll call out here is that over here in the docs on the left-hand side, there are certainly there are a number of, under other use cases, there are a number of tutorials where the idea is that, if you come and you say, I care about whatever, Kafka, then this tutorial will sort of walk you through putting Opa in place for Kafka. And so we try to make it pretty easy to get started with some of the most mature integrations that exist. The first question that you asked was really more around Postgres, I believe. So we'll get into that we'll get into sort of the more details around how these integrations work in a little bit. But what I will say is that the vast majority of integrations are very simple in the sense that, if it's Kubernetes or microservices or Kafka, they will just decide to reach out and talk to Opa and say, you know what, can you please give me a decision for this kind of policy query? So, is this API authorized? Is this pod or ingress authorized? Is this right to the Kafka topic authorized? There is a new collection of sort of, there's a new class of use cases where it's more like a query rewriting kind of integration. So these are sort of new in the sense that the idea is that instead of let's say Postgres calling out to Opa and saying, hey, can you please tell me what's authorized or not? Instead, what we'll do is sort of take a query that's being intended for Postgres, use Opa and use Opa to help rewrite that query to add whatever additional basically where clauses or selects that are necessary to enforce that policy. So like I said, that's a newer kind of use case. I won't go into more detail here today, but there's certainly blogs and we can point you to some of the examples of that.
Oh, that's awesome. That is something we can see in the discussion zone probably. And yeah, by the way, if if anybody have questions, please just ask them in the chat. Yeah, let's continue. Thank you.
Great. So that was a good question. So now I want to talk for just a couple of slides about the community around Opa. I know that certainly one of the things that I look for when I'm looking at an open source project is what is the community that's built up around it. So I mentioned this earlier, but the Open Policy Agent is a completely open source project. We founded it at Styra back at 2016. And then 2 years later, we donated it to the CNCF. When you donate to the Cloud Native Computing Foundation, when you donate it to the CNCF, you typically start as a sandbox project. They have 3 levels of maturity: sandbox, incubating, and then finally graduated. Graduated would be where Kubernetes and Prometheus are. So sandbox in 2018, about a year later into incubating, and that's where we are today. In terms of the landscape, this is probably a bit old, this picture of the landscape of the CNCF different projects, as well as, I believe, the vendors. In terms of all the different projects within the CNCF, the only project, at least to my knowledge, that exists within the incubating or higher levels that is focused solely on policy would be the Open Policy Agent project. In terms of sort of contributors, the CNCF does have a nice dev stats portal if you want to go and look at who's been contributing to it. But there are plenty of different folks that have been doing that for a while now. When I think about the community, there are certainly the vendors who are contributing. There's the sort of ecosystem in which it exists, but then there's also the end users. And for me, this is another important thing to think about when I'm looking at a new project, which is, who are the end users? How are they using it? I'd like to hear from them talk about how they're using it and what it's good for, where are the rough edges. And so I always like to point people at a couple of very dense sort of places where you can go to hear from a bunch of end users about how they're using OPA. So KubeCon US 2019, so that was about a year ago now. It was the last physical KubeCon. So a lot of the folks that are using OPA are talking about OPA at the KubeCon conferences. And so back in 2019, for whatever reason, there was just a good collection of end user talks. Here, the sort of top collection there are sessions at the actual KubeCon. And so here we heard, and what you also find is that there are different end user companies talking about different use cases. So Yelp was talking about using OPA for microservice authorization. Google was using it more so for Kubernetes, but then they also talk about how that helps with the service mesh. Goldman Sachs was also talking about using it for Kubernetes. There it was actually a pretty cool application where they were using OPA to ask what additional resources needed to be deployed when someone created a new namespace. SNCC is looking at it for throughout the application lifecycle, but mainly CI/CD. Reddit was looking at it for Kubernetes, and so on. What I'll also call your attention to is that we ran an OPA summit, about a half day, where we had a bunch of end users come and talk about how they were using OPA, and it was a great event that we'll do again at some point. And so here, Capital One was talking about sort of an update. They had done an earlier talk about how they were using it for Kubernetes. Well, they gave us an update at the summit. Chef was talking about how to use OPA within an application. So remember, I gave the banking application example. Every time if I log into my bank and I try to withdraw money, there's an authorization problem that needs to be solved there within the application itself. And so Chef was talking about how they did that. Pinterest was a great one because they talked about multiple use cases, and they talked about like microservices as well as Kafka. They had great scale numbers. So there they were seeing 8 million decisions being made every second sort of globally across all their infrastructure. And that was with a caching layer on top of OPA. Without the cache, just OPA itself was making about 500,000 decisions a second. TripAdvisor was talking about Kubernetes. Atlassian was talking about microservices as well. So definitely, I would recommend if you're looking for some end user talks, those are great. Those are a great couple of venues to look at. Okay, so that was all I wanted to say around community. I'll pause again to see if our experts have any questions. If not, I'll just continue.
Just one more question from me. You and Vladimir talk about integrations before, and my question is, could we somehow check these integrations releases before the installation? Maybe some signature or something like that?
Sorry, checking what? So checking the policies, checking that the integrations are working. What did you?
Checking the integration release, that it was not corrupted by somebody.
Oh, I see. Yeah, checking that the bits that you're using to do the integration haven't been corrupted. Yep. So yeah, I don't, each of the different integrations, this is, it's a community project. So each of the different integrations addresses that sort of software supply chain a bit differently. I don't think I know of any of those integrations that have signatures or whatever to make sure that they haven't been tampered with. I think that usually what people do is they'll go ahead and deploy the integration. They'll get it working in test, and then they'll promote it to stage, and then eventually they'll go to production. But usually when you put one of those integrations in, you've tested pretty heavily, and that seems to be enough for right now. The other side of that is, the other piece of that I'll mention though, because I probably won't otherwise, is the policies themselves. That's actually where we've seen more people worry about having sort of signatures around the policies to make sure that they weren't tampered with. And one of the things that OPA does support is signing those policies. So let's say you check it into Git, and then you have some automated process to deploy it to OPA, and I'll talk about that piece a little bit. But you can go ahead and digitally sign those policies, and then when OPA receives the policies, it will go ahead and do the signature checking and verification, and it will refuse to activate a policy that's not been properly signed. So that piece is worth mentioning here.
Great.
Okay, so that's a good question though. All right, so let's go on to architecture. So this is sort of like how we think about using and rolling out OPA, throughout our infrastructure. So here's a picture I showed everyone a little bit ago. And this is not a good architectural picture. It is a conceptual picture of how OPA is designed to sort of provide you one unified tool set, framework, and language to handle and enforce authorization policies across the cloud native stack. But architecturally, it's inaccurate because what this sort of shows is that OPA is running as a centralized service. That is not how OPA was designed. You can run it as a centralized service, but OPA gives you far more architectural flexibility than that. So the way that we designed OPA was really to make sure that it could be deployed in this cloud-native world. And so one of the key requirements around authorization in the cloud-native world is that availability and performance is super important. So let's take the microservice use case because it's a great example of this. Imagine you've got 500 microservice instances running throughout your infrastructure. Every time one of those microservices receives an API call, it needs to make a decision. Is this authorized or not? Now, imagine for a moment that you had a centralized service that was responsible for making those authorization decisions. Then every time a microservice would receive an API call, it would have to make another and receive another API call in order to understand whether or not that original API call was authorized. So that's not how OPA was designed. OPA was designed to in a sort of a distributed or a decentralized model. So the idea behind OPA is it is a small binary. It is about a 20 meg binary. You can run it on the same server as whatever software systems need authorization decisions. So the idea here is that you might have not one instance of OPA or not 5, but you might have 500 instances of OPA, one for each of those microservices. And so in that way, and so because you're running OPA on the same server as the microservice or as the Kubernetes cluster or as the CI/CD pipeline, because you're running on the same server, the microservice just needs to make a hop from one process to another on the same server. And so because of that, OPA allows you to achieve roughly the same availability and performance results that you would have had you left that policy hard-coded into that microservice or into that Kubernetes cluster. And so that's one of the key design decisions around OPA, that it is an agent. After all, agent is in its name, so you run many, many instances of OPA, one on every server. And obviously, that gives you those two benefits of being able to simultaneously decouple policy from the underlying service so that you can use OPA for everything, but also it's running physically close to the software that needs those decisions. So the way we like to describe this is OPA gives you a logically centralized way of managing and understanding policy across the cloud-native ecosystem. But when it comes to enforcing those policies at runtime, it is physically distributed. And so that's pretty crucial. Now, OPA is architecturally pretty flexible. You can run it as a sidecar. You can run it at the edge, as I've just depicted here. But you can also, if you need a centralized service for authorization as well, and sometimes that's also useful. It's sometimes complementary. You can bundle multiple OPAs together, run them in a scale-out mode, and you can build that service around OPA as well. So I like to think of OPA as a building block for authorization and policy that was designed for the cloud-native world. So let's look at how one of these integrations works. The first, the way that this works, I sort of described earlier a little bit, which is that we have some service there in gray, and that service could be anything. It could be the Kubernetes API server, it could be a microservice, it could be Kafka, it could be a Linux PAM module. That service decides that it needs an authorization decision somehow in some way, and so that service sends OPA a policy query. The OPA then responds with a policy decision back to the service. It is the service's responsibility to enforce that decision. It is OPA's responsibility to make the decision. So that's how we see the separation of responsibility there. Now, there are a couple of important things about that integration that you see called out here. So I'll just talk about each one of them one at a time. So the first of which is that the service, when it hands the policy query over to OPA, it can hand over really any arbitrary JSON value. So OPA. So in the case of Kubernetes, maybe the Kubernetes API server hands over 100 or 200 lines of JSON that describe the pod or the ingress or whatever the resource is. If the service is a microservice API, if it's a microservice, it'll hand over maybe a JSON object that has a method, a user, and a path. Opa doesn't understand the real world semantics of those resources. It doesn't understand what a method, a user, or a path is. Opa itself does not understand what a Kubernetes pod or an ingress is. Rather, I, as a policy author, I know what that JSON object that gets handed over means in the real world, and so therefore I can write the appropriate policy to make the correct decision. This ability for Opa to accept policy queries that just look like arbitrary JSON is part of the power of unification. It is how you can deploy Opa for all of these wildly different pieces of software. It's because we did not have to build a bunch of information into Opa about those real world systems. So that's one pretty key idea around Opa, is that those policy queries can be arbitrary JSON values. The second thing that's important there is that is this policy, this Rego down there at the left-hand side, lower left-hand side. The idea here is that when that arbitrary chunk of JSON comes into Opa, now that policy language, which we call Rego, needs to be expressive enough to allow you to say whatever policies you want about that arbitrary JSON data. And so, for example, suppose you want to write in Kubernetes a policy that says all binaries or all images that get run on the Kubernetes cluster have to come from a trusted registry. Well, how do you do that? Well, you're handed over 200 lines of JSON. So that policy language needs to allow you to dig down through that deeply nested data, extract the array of containers. Then it needs to allow you to iterate over all those containers and for each one, find the image field. Then it needs to allow you to do some string manipulation to figure out whether that image is coming from a trusted registry or not. So all those kinds of functionality are things that Rego provides and that you can write as a policy author. To give you a bit of comparison, Rego is sufficiently expressive to allow you to express role-based access control, attribute-based access control lists, even IAM policies. All of those are sort of a fragment of what Rego allows you to do. The third thing I'll mention here on this slide is that data JSON. You might be asking yourself, what is that? Well, I mentioned earlier that Opa allows you to express context-aware policies that are aware of the world in which they're being evaluated. So a good example here is PagerDuty. So let's suppose that the policy you want to write says that only people who are on call can SSH to production servers, can change resources on the production Kubernetes cluster, and can query production databases. Well, who's on call? The servers don't know, the databases don't know, the Kubernetes cluster doesn't know who's on call. Your LDAP or your IDP, whatever your authentication service is, they don't typically know who's on call either. Usually on-call information is stored in some third-party service like PagerDuty. And so what you can do with Opa is extract that list of on-call engineers from PagerDuty and inject it into Opa as long as that data looks like JSON. And so then therefore, once Opa has that data available, then, well, we already know that Rego allows you to write policy over arbitrary JSON data. And so therefore, you as a policy author can use that external data however you like to enforce whatever policies you want. The last thing on this slide here is that policy decision. You'll note that it says the output can be any JSON value. So certainly the most popular way that people get started with Opa is thinking of Opa as solving the authorization problem, as making allow-deny decisions or true-false decisions or ones and zero decisions. And certainly Opa is good at that. But that the policy decisions Opa allows you to express are much broader than that. So you can return any arbitrary JSON value as a policy decision. For example, if you wanted to write a policy that described a rate limit, you would need to return a number. If you wanted to write a policy that expressed where an application should be deployed, well, then maybe the decision is an array of application or of cluster names. Maybe sometimes you want to return multiple values, like you want to return whether the request was allowed, an HTTP status code, and maybe a list of error messages. Well, in that case, you need to return multiple values, which Opa allows you to do by returning a JSON object that has multiple fields. So that's another dimension. If I think of all these things together, to me, that means that Opa really does serve this title of a general purpose policy engine. It is a general purpose policy engine because it goes and allows you to solve authorization problems, absolutely, but allows you to do quite a bit more than that as well. Importantly here, when I look at this sort of picture, the other thing I'll call out in terms of architecture is that Opa is often run as a sidecar, as we sort of discussed. You can run it as a daemon as well. You could spin it up as a service if you like. You could also integrate with Opa as sort of a library. If you're using Go, Opa was written in Golang. And then a newer kind of integration is that you can use, we're getting to the point where you can compile Opa policies down into WebAssembly, and then any language that supports WebAssembly, you can then go ahead and run those policies directly within the process, within the programming language process that supports WASM. Any questions from our experts? I've got a couple of examples that I'll show, but questions would be good too.
Before we get to the examples, can you please clarify? It looks like parsing and composing JSONs is not the fastest thing on earth. And do you have any like ideas or suggestions to optimize that? I don't know, to use some data formats that doesn't require parsing and composing, or is it not the issue? Probably.
Yeah. So one of the nice things about having this sort of distributed model for enforcing policy is that the performance requirements are quite a bit different, right? So in like a microservice world, when Netflix picked up Opa, the performance requirements that they needed were on the order of like 1 millisecond response time. And so when you have that kind of 1 millisecond response time, because you're distributed, you don't need to worry all that much about parsing of JSON and serialization and that kind of thing. So far we haven't found it to be problematic, and the nice thing about using something like JSON is that it's all human readable. It's very easy to do integration. It's very easy to do debugging. So the overhead of like using JSON for this communication language is really not something that we found to be a problem today.
Okay, thank you. I'm all yours to see how it works.
Yeah, great. Good question. Okay, so let's look at a couple of examples. Here is sort of our picture of our cloud native stack. So let's zoom in and look at how that integration works for a couple of concrete examples. So the first is sort of this microservice world. So here, one of the questions that we'll sometimes get is, well, the picture on the last slide kind of showed the service talking directly to Opa. So does that mean that we need to change our microservice to talk to Opa? And the answer is, well, no. What a lot of people end up doing is using the network, using a network proxy to go ahead and do the integration with Opa. So the way this works, if you haven't seen this before, is that you configure basically all of this, or the network proxy here, the microservice and Opa, they're all running on the same server. And so what you do is you configure the network proxy to sort of at the IP tables level usually, so that all network traffic to and from the microservice goes through the network proxy. So the proxy's job is to sort of take a request, and then what it can do is integrate with Opa. And so then it's that network proxy that's sending a request to Opa that says, hey, is this API call authorized or not? Opa responds, and then if Opa responds and says no, that API call is denied, then the network proxy can go ahead and drop the request or return a 403 or however you want to make that happen. And in that case, the microservice won't even see the request. If instead Opa allows the request, and the network proxy will forward it to the microservice will go ahead and send a response back. And then usually what happens is the network proxy will go ahead and return the response that the microservice sent back to the caller. One thing, though, that we've seen a couple of folks start doing is looking at using Opa not just for making an API authorization decision, but also using it for what's called here response filtering. So the idea here is that, let's say that microservice returns a JSON object. What you can have, at least some of these network proxies do, is send that response to Opa and say, hey, Opa, can you please filter this out? Can you please remove the rows or columns that this end user isn't allowed to see? And then Opa will return, in that case, that filtered JSON object to the network proxy, and then the network proxy can return it back to the caller. Now, there are all kinds of caveats or limitations around when this is a good idea, but nevertheless, it is another good illustration of how Opa can be used for something other than authorization, right? Because obviously in this case, it's being handed a chunk of JSON, it does some filtering, and it hands back that chunk of JSON. One of the nice things about this particular integration is that there is no way to sort of circumvent it, right? You sort of set up the enforcement that all traffic goes through your network proxy at the operating system level, and then there's no way for the microservice author to forget or to circumvent those authorization checks. Here's a second example, this time with Kubernetes. So remember that anytime an end user is trying to create I always use the examples of pod or ingress on a Kubernetes server, on a Kubernetes cluster, that request goes through the Kubernetes API server. And so there are a number of different pipeline stages in that API server, but here we're showing authentication, who are you, authorization, that would be Kubernetes RBAC, and then finally there's admission control. This admission control stage is where people typically will integrate OPA. The idea here is that admission controller will hand over to OPA the full, let's say, 100 or 200 lines of YAML or JSON that we're also familiar with. To open says, hey, is this pod or this ingress? Is all the configuration options for this pod or this ingress, are they safe? Is this safe to deploy to the cluster? If OPA says yes, then it goes on into etcd and makes its way out into the cluster. On the other hand, if OPA says no, it's not safe, OPA will typically return a bunch of error messages that the API server will then send back to the end user. Again, this is a native integration, meaning Kubernetes supports this kind of integration directly, and so there's no way to circumvent it once you've got this set up. Third example here, again, another popular one is the CI/CD pipeline. So, we all know how these CI/CD pipelines work. Somebody tries to commit some code or tries to commit some code, and so we can set up any number of PR checks that we like. What some people do is that they'll set up a PR check that'll go ahead and run OPA over some of these structured files, whether they're Kubernetes files or Terraform files or Python ini files. You can use OPA if you can take that file format and convert it into JSON, then you can hand it over to OPA and say, hey, run my policies over this structured file format. Again, like the people that control those PR checks are the ones who are actually responsible for enforcing the decision once OPA returns it. And so nevertheless, what you get is another good example of interacting with OPA to get policy decisions. All right. Any other questions here from the audience or from our experts before we talk a little bit about the policy language as well as the tools that OPA provides?
Let's dive into our policy language. We have 20 minutes left, so let's see how it feels.
Perfect. Yeah, and this will be good. So I'll kind of feel this out and figure out how much time we want to spend in the slides and how much time we want to do this as part of a demo. All right. So one thing that I mentioned a little while ago is that one of the ideas behind OPA is that it embraces this idea of policy as code. So policy as code here just means that there are artifacts. There is a file format where you can express policy, and that policy is written in a format that machines can understand. So that's sort of the idea for us behind policy as code. And one of the benefits of embracing policy as code is that now you can put your policies through the same kind of life cycle that you put your traditional software through. And so here we're kind of illustrating that. That here the policy development lifecycle stages. So the first thing you need to do is think about requirements gathering, just like you would for traditional software. What policies are you trying to enforce? What data do those policies depend on? Where can you enforce those policies? And then once you understand what those requirements are, you can think about integrating OPA and deploying OPA. And once you get that out there, then you need to think about authoring policy. All right. So now I've got my spreadsheet or my Word doc or my wiki that describes what the policy should be, maybe in English or Russian, as the case may be. And now I need to actually author that. I need to translate that into code. And so that's where you're writing policies, where you're writing Rego. And then there's the CI phase, which is that maybe you've got multiple people throughout the organization where you that are all writing policy, that maybe all are and that you're all maybe collaborating to go ahead and make the overall policy decisions. Well, then you want to do some testing. You want to be able to assemble that policy from the different stakeholders, maybe from the different Git repos where maybe you're checking that Rego into. You want to be able to test those policies and make sure that they're all saying what you think they say. And then what you also maybe want to be able to do is build some artifacts, just like we build binaries for traditional code. OPA allows you to build artifacts as well that you can then ship around. And that we've already touched on, where you can sign those builds. And then there's a deployment phase, which is that remember that OPA is potentially distributed. There may be 500 instances of OPA. And so there's some way that you need to be able to hand all of those policies over to the appropriate OPAs and make sure that they've successfully downloaded them and so on. And then there's monitoring, which is, well, okay, OPA's out there and running. Is it healthy, right? I mean, it is a process like any other, and it needs monitoring. And then there's finally logging. So all those decisions that OPA is making, those are describing pretty crucial security information about, who is authorized, or maybe even more importantly, who is not authorized, but nevertheless, we're trying to perform certain actions. And so you need to be able to record and log all those decisions. All right, so all of those stages sound pretty similar to the standard software development lifecycle. And so OPA endeavors to provide tooling for all these different stages of the lifecycle. So we've already looked at the different integrations, and this is a great place to get started with OPA. I certainly recommend going through one of those tutorials that I showed you. And this just gives you a sense as to what the different enforcement points are that people have used and used successfully. And that's pretty crucial around requirements. When it comes to authoring policy, OPA has a number of integrations with some IDEs to help you write policy. So VS Code and IntelliJ. There are plugins for writing policy. There's also, and you'll see this in the demo, a playground where you can write that sort of just in your web browser. You can try writing policy, and we've got some examples there. And then there's a REPL. So a REPL is just a sort of a command line IDE if you haven't used one before. In terms of CI, there's a number of different tools. So there's a unit test framework, there's a profiler, a benchmarker, there's obviously a compiler and a build step. We definitely recommend everybody using that unit test framework. For whatever reason, some people think that because it's policy, they should just deploy straight out onto a live system without running unit tests. We definitely recommend you write unit tests for your policies. When it comes to deployment, one of the interesting things about OPA was that it does have a number of management APIs. So OPA is an agent, right? It is designed architecturally to have many copies of OPA running and making decisions throughout the infrastructure. And so necessarily then OPA is not the source of truth for policy. You don't go to OPA and say, here's my policy, please store it and make sure that that all the OPAs can get it when they need it. Instead, OPA is really this agent. It's really this host local cache that has in memory a copy of those policies. But what question that begs is, well, how does OPA get all those policies? How do you deploy those policies to OPA? So OPA has a number of different options there. It has a bundle API that allows you to just configure OPA to periodically download bundles of policy from a centralized service. It also has a push API, so if you need to, you can push policy into it. It also has a couple of different ways of getting data in sort of at runtime. When it comes to monitoring, it has a Prometheus endpoint, so you can monitor it that way. It also has a status API that will periodically upload status information to a centralized service. And then when it comes to logging, it has a decision logging API. So when OPA logs decisions, it can store them in JSON, actually. And so the nice thing here is that, the input that came in, well, that is stored in JSON. The decision that was made, that is stored in JSON. And then you can even include in that decision log entry a pointer to whatever policy was used to make that decision. So if you store all that information, then you can go ahead and replay those decisions at a later point in time, if you so desire. Okay. Now, one thing that I'll call out here is that OPA does have all these tools throughout this life cycle. And so we can continue to provide a bunch of tooling to help you with these different aspects of policy as code. The thing, though, that at some point is something that you're going to have to work out is, well, you're going to have to write those policies, right? Like, we can't, OPA, regardless what kind of tooling we write, there's no way for us to guess what those policies are in your head or in those wikis. And so one of the things that we do spend quite a bit of time on is helping people write policies. And so when you're writing policies, the most important thing to understand is Rego. Rego is the language that OPA understands and for expressing policy. And there are a few design principles around Rego that I'll call out here on this slide. So the first of which, the high level bit, is that Rego is designed to be a purpose-built policy language. It is a domain-specific language. It was purpose-built for the OPA project. And there are a couple of dimensions in which that I want to call out here. So the first of which is syntax. So Opa's Rego's syntax was designed to mirror the syntax of real-world policies. So what we kind of want is for when people write policies in English or Russian, in a wiki, a PDF, a Word document, wherever they write it, we want the syntax of Rego to sort of be somewhat close to those natural language policies. And so here the idea is that, let's say, allow this request if user is Alice, right? That's a very simple sort of policy that you could write. And so when you write those very simple kinds of if statements in natural language, well, it turns out that the statements in Rego that you write are also simple if statements. And so the vast majority of all the statements you'll ever write in Rego are just if statements. The second thing that I'll call out here is semantics. So we've talked about how Opa sort of requires JSON data coming in. It's not so much JSON data that Opa is wedded to. It's more this idea that hierarchical data is really important here. And it's really important not because we want it to be with Opa, but rather because hierarchical data is pervasive in the cloud native ecosystem. It's very difficult, and we actually tried in the early days, to use a policy language that doesn't have first-class support for hierarchical data. So when we designed Rego, we made sure that it had excellent first-class support for deeply nested data. And so the way you'll see that is you'll see a bunch of expressions that allow you to just sort of dot down into the deeply nested data and to iterate over the arrays that you find there. The third item here is really algorithmic. So conceptually, the policy language, Rego was designed to be a policy language, and as part of that, what we want you to be able to do as a policy author is focus on correctness and maybe maintainability of those policies. What we want is for Opa to carry the burden of and to be the thing that is most responsible for the performance of making decisions using whatever policies you've written. Now, obviously, that's a pretty clear goal for us. And so what that means is that the sort of core language of Rego is closer to a query language like a SQL than it is to a traditional programming language. In particular, Rego was designed to be less than Turing complete. It does not allow you to express any arbitrary computation. It was designed specifically for policy. So here's my one slide overview. I'll show you this in a little bit, but we've put together an academy that sort of walks you through an introduction to Rego. And so you can sort of see it built up from the ground up. Here's my one slide overview of Rego. When you're writing Rego, there are really two things you're doing. You're writing rules, and each rule is one of these if statements I talked about. Each rule that you write effectively makes a policy decision. And so the rule itself is really just a conditional assignment. Conceptually, what you do is you say, if a bunch of conditions hold true, then I'm going to assign this variable a value. And so an example that might be saying that I'm going to assign will allow to the value true if it's the case that the user is Alice and the action is read. And it turns out that basic kind of construct is sufficient to express a broad array of policies. So here would be how you'd write this in Rego. You might say allow equals true. So here we're assigning the variable allow to the value true. If, and instead of if, we just use the curly braces. And then here, user is Alice, action is read. Those should be pretty straightforward. And then instead of and the word, we'll use a semicolon here. Turns out you can also use a carriage return. But nevertheless, that's sort of a very simple example of the kind of policy that we see. And then moreover, if you want to look at what some of the different conditions are that you can put in what we like to call the body of the rule or the condition part of the rule, you can read through those there. And then there are a number of different kinds of assignment that you'll see. When we do the demo, I'll show you two different kinds of assignments. So one of which is that you're assigning a variable to a value, just like you see here. But the other thing that you'll see is you can assign an element to a set. And for that, it'll be pretty straightforward and obvious why we're doing it that way. Okay, and then the second thing that you do is you'll organize these rules into policies, or into packages. So the idea is that you can associate with a collection of rules a name, and then you've basically got modules or namespaces as you like. And that's pretty useful for organizing policies, for delegating them, for collaborating with different teams. You could have a networking team write one policy, you could have a compute team write a different policy, and then you can sort of delegate the decision to each of those different policies. All right, so we have about 10 minutes left. I think it's a good idea to go ahead and switch over and look at the demo, because I think that will tell this story very well. Yeah. Okay. So so the demo that we're going to do is pretty similar to. I'll pull up this one quickly. The demo that we're going to do sort of looks like this. What we're going to do is we're going to have. I've got a Kubernetes running. It's a mini kube running, but I've got a Kubernetes cluster running, and then I've got an application running. So it happens to be Kuma's demo application. And then what we've done is we've integrated Opa with both the Kubernetes cluster as an admission controller, and we've added Opa as sort of a sidecar next to the nodes in the Kuma application. And so then what we're going to do is we're going to look at the policies that you put in place for both of these. We'll see, we'll look at the applications. We'll see that as we change policies, that the behavior of those of the Kubernetes cluster as well as that Kuma application are going to change. So first of all, let's start with the Kuma application. So here we go. This is Kuma's application. It's a nice, pretty kind of a piece of software here. What you'll notice is that as you click on one of these read reviews, you get more information about whatever this item is. And so that's sort of typically how this application works. Now let's look at one of the policies that's the wrong one. Let's look at the policy that we are using to control that application. All right, and so what you'll see here is the Opa Playground. I mentioned this a little bit ago, just a couple of landmarks here so it doesn't look quite so foreign. On the left here is just a text editor, all right? That is just a file that this is showing you a concrete Opa policy. On the right-hand side, this is sort of also an IDE. So on the right-hand side, you've got the input that you might want to use to test this policy on the left-hand side. You don't have to. But you can, and then you also see the output. So what you can see here is that if I went ahead and hit the evaluate button, what this will do is it'll take this policy, run it against this input, and as you can see, this is just sort of like an Envoy. This is the YAML or the JSON that Envoy hands over to Opa, and then what you see is the output down below. So here we see that allow is true. All right, so that's kind of the IDE, and what I'll show you here on the left-hand side is the policy that we've got in place is really got two allow statements. All right, and I won't go through the details here, but each of those different allow statements is allowing a different API. So this is allowing get to /items. This is allowing to get to the reviews for one of those items. And so what you'll notice is that, let's go ahead and comment this out, and we'll go ahead and publish it. So the other thing that this playground allows you to do is not just be an IDE, but you can also sort of connect a live Opa to the playground and use the playground as a non-production way of distributing your policy, deploying your policies to those Opas. So the way that we have it set up here is that when I close that fairly quickly, if you want to use this, you go ahead in here and we give you we give you exactly the configuration for Opa that you need to actually have it download its policies from the playground. So let's go ahead and look at now what the result of let's see if Opa has happened to download the policy yet. Okay, so in this case, I refreshed the page, so everything looked fine. But then when I went ahead and asked for the review for this item, we get basically a 403. And the reason we got a 403 was because when we went in there and changed that policy, it went ahead and removed, it stopped allowing the request to that items API. All right, so very simple. What you saw there was that as we change policy here in the editor and we go ahead and publish it, Opa pulls down and downloads that policy and it starts enforcing it right there on the spot. So that's a great example of microservices. The other thing that I'll call out here is we can do the same thing for Kubernetes. And so what you see here is I've just got a different tab open. It's got a different policy in it. Here, the policy might look a bit more complicated. It's not a simple allow deny rule. It's a deny rule where what we're doing here is we're actually generating error messages and handing those error messages back to the user. So here I will go ahead and pull up the terminal. So let's go ahead and look at a pod. So here we've got Kubernetes. Here's a pod. It's a super simple pod, obviously. I'm just running Nginx. And so that's the pod. If we flip back over to here, the policy that we've actually written here basically requires all container images to come from huli.com, okay? And so now if we look at this request again, or if this pod again, we see that this is an image in Nginx. It does not come from our trusted registry, huli.com. So now let's go ahead and kubectl apply it, pod.yaml. And so what you see here is that Kubernetes is actually going to enforce this policy. And the way that it enforces that policy that we saw is that it'll go ahead and run this request against OPA. OPA will return an error message if it's not allowed. In this case, you see that error when creating pod, the Open Policy Agent webhook denied the request. And then it's this error message, the image nginx failed to come from the registry, huli.com. So obviously this error message is coming directly from that policy. I think if we had more time, I would play around a little bit more and show you that if you disabled this particular rule, then when you went ahead and started it and tried to deploy that pod again, that you would see that the pod would be allowed. But I think for sake of time, you can all imagine that. Okay, the other thing I wanted to call out quickly, because I promised you I would do it, is that there is an academy on how to write OPA policies. So you can go to academy.steyr.com, and then there's just one course. It is a policy authoring on Rego. And so we'll just sort of walk you through from a bottoms-up approach. Here's how you write basic Rego expressions. Here's how you build those into rules. Here's how you write some of those more sophisticated rules that return error messages. Here's how you even do iteration. And then finally, how you break those rules up into packages. Okay, so with that, I think we are just about out of time. And so I will say, finally, thank you all for giving me your time. Hopefully you found this instructive and useful. And I'd also like to thank our experts for joining me and asking such great questions. And now, if there are any other questions, I'm happy to take them.
Vladimir, go ahead. Oh, Max, go ahead.
Yeah. This time it will be me. Small question. Before the talk, I have checked that the first commit to the Open Policy Agent was made in 2016. Am I right, Tim?
That sounds right. Yeah.
Yeah. And the question is, when will you release the first major version of Open Policy Agent, and what reason stopped you from that?
Yeah, that's a good question. I think we talk about doing that from time to time. For the most part, what we find is that people are happy with using the version that exists. It's been battle hardened for years at this point. So I think the thing that we want to make sure we do once we hit that first major release is be very comfortable with guaranteeing backwards compatibility of even the sort of minor language features. I think that for the most part we do that anyway, but there are a number of those rough edges that we'd really like to sand off before we go ahead and deploy it. But otherwise, I think but like I said, it's been battle hardened for years and used in production by plenty of folks all over the world. So it's certainly ready to go. There's no don't let the versioning think of the versioning as just us being a bit careful and wanting to make sure that everything is really in a good spot before we bump it.
Gentlemen, keep in mind that we have 1 seconds left for this talk, and I have to say thank you all for joining us for tonight, and see you in the discussion zone. And this is the final talk on the DevOps conference. Thanks for coming, Tim. Thanks for coming, Max and Vladimir. See you around.